Hello everyone, and welcome. Today in this explainer, we're going to be explorers. We're diving into the amazing power of multiplying numbers in a very special way. Imagine you have a superpower that lets things grow incredibly fast. In math, we call this a power play. It's this beautiful concept that actually helps us understand the whole universe, right down from the smallest atoms up to the largest galaxies. So let's take a deep breath, focus our minds, and begin our mathematical journey together.
Our agenda today is pretty clear and straightforward. We'll start with the magic of folding, then figure out exactly what exponents are. After that, we'll learn the rules of the game, understand negative powers, and finally, look at writing very large numbers. All right, part 1, the magic of folding. Let's kick off our journey with a pretty mind-bending physical experiment.
Meet our friends from your textbook, S2 and Roxy. They're looking super curious right now as they chat with their wise teacher, Al. They're asking a really fascinating question about just a simple, thin sheet of paper. Much like the pages right there in your notebook.
I want you to take a guess in your mind right now. If you take a large sheet of paper and you fold it exactly in half, and then you fold it in half again, and you do this 46 times, how thick do you think it's going to get? Do you think it'll be as thick as a huge textbook? Or, I don't know, maybe as tall as your school building? Just hold that guess in your mind for a second.
If we map this out, notice how with every single fold, the thickness exactly doubles. It moves from a tiny 0.002 centimeters to 0.004 centimeters, then to 0.008, and so on. It's just multiplying by 2 over and over again. Now this is truly hard to believe, but the math doesn't lie. Because that thickness doubles every single time after 46 folds, it increases so much that it travels over 7 lakh kilometers. That is literally thick enough to reach all the way from the Earth to the Moon. No way, right? But that is the incredible magic of multiplying a number by itself repeatedly.
Moving on to part 2. What are exponents? This incredible, fast-paced doubling we just talked about is called multiplicative growth. And mathematicians actually use a very special shorthand for it.
Let's break down how we write this. Imagine a big number 5 sitting right in front of you. This normal-sized, large number at the bottom is what we call the base. The base is simply the number that's going to be multiplied by itself. Now, imagine a small 4 sitting high up on the top right shoulder of that 5. This tiny number is called the exponent, or sometimes we call it the power. It tells us exactly how many times we need to multiply the base by itself. Whenever you see this, you should read it out slowly and carefully as 5 raised to the power of 4. So, this simple notation, 5 raised to the power 4, just means we write down our base, the number 5, 4 times, and multiply them all together. So it's 5 multiplied by 5, multiplied by 5, multiplied by 5. And when we actually calculate that, it gives us 625.
All right, part 3, the rules of the game. Now that we know what the base and the exponents mean, let's learn the laws of exponents.
The very first rule is super simple. When the base is the exact same, let's represent it with the letter n, and we are multiplying the terms, we just add the small top numbers, those exponents, together. So n raised to the power a multiplied by n raised to the power b simply becomes n raised to the power of a plus b. Now rule 2 is for when you have a power of a power. If a base with an exponent is sitting inside a bracket and it has another exponent sitting right outside the bracket, we actually don't add. Instead, we just multiply those two small numbers together. So n to the power a, all raised to the power b, becomes n to the power of a multiplied by b.
So here are the main rules all together. We just discussed the first and third rules. Take a quick look at the second rule. If we divide identical bases, we subtract the exponents. Pretty logical, right? But carefully notice that very bottom rule. It's a special one. It tells us that any non-zero number raised to the power of 0 is always equal to 1. Whether it's 5 to the power 0 or even 1,000,000 to the power 0, the answer is always just 1.
Moving to part 4, understanding negative powers. Now so far, we've only looked at positive exponents, right? Numbers like 2, 3, or 4. But as curious explorers, we have to ask, what happens if that small exponent number on top has a minus sign? Well, please don't let the minus sign confuse you. When you see a negative exponent, it's really just a clear instruction to create a fraction. All it means is you write the number 1,
Draw your division line, and then write that exact same base below the line, but you just change the exponent to a positive number.
Let's walk through an example together. Let's say 2 raised to the power of -4. If we follow our rule, this simply becomes the fraction 1 divided by 2 raised to the power of +4. And since we know 2 to the power of 4 is 16, the final answer would just be the fraction 1 divided by 16.
And finally, part 5, writing very large numbers. Now you might be wondering, why do we even need all these rules? Well, in the real world, we use exponents to clearly write huge numbers. Things like the entire population of the city of Mumbai, or the vast distance between planets, and we do it without having to write down dozens and dozens of zeros.
For instance, think of a normal number, like 5,900. We call this standard form. But you can write that exact same number in what we call scientific notation, which looks like 5.9 multiplied by 10 raised to the power of 3. Both of these equal exactly 5,900.
Scientific notation is incredibly useful. By writing a small decimal number between 1 and 10 and then multiplying it by a power of 10, we completely avoid counting endless zeros. When you're writing out the population of India, or say the distance to the sun, this method prevents silly counting mistakes and makes our math super clean and really easy to read.
Just like those bright classmates you might see taking notes and discussing problems together, you now have the tools to read, write, and play with the very biggest numbers in the universe. You understand the base, the exponent, the laws that guide them, and exactly how to use them to write giant numbers clearly.
As we wrap up this explainer, I want to leave you with a really fun challenge to test out your new skills. This is actually a puzzle right from your textbook, and it's called Tremendous in 10. To practice at home, try to create math expressions that equal exactly 10. For your first round, try doing it using only addition and absolutely no exponents allowed. Then, once you master that, you can change the rules. Try adding multiplication into the mix. Or finally, use your new superpower and allow exponents into the game. As you practice that, I'm going to leave you with this final thought. If folding a piece of paper 46 times gets us all the way to the moon, what mathematical superpower might you unlock if you folded it just one more time? Math truly is a language of infinite possibilities. Thank you so much for joining me today, and keep exploring the universe through numbers.